Welcome back to Math Videos with Nathan, and today we'll be talking about transformations of sine and cosine equations. So the base equation for both sine and cosine is y is equal to a cosine b x minus h plus k. Now, cosine and sine can be evenly just switched out with one another because the equations are going to be the exact same. To begin, we have to rely on our previous skills from transformation units. As we know, h is going to be the horizontal change, and at least in the past units, we called it a horizontal change. When we're talking about the transformations of sine and cosine, the name changes from a horizontal change to a phase shift. So whenever something affects that h, you're going to call it a phase shift. Similarly with k, as in the previous transformation units, was called a vertical change. However, now it is called a vertical shift. So we know that h is going to be called a phase change, and k is going to be called a vertical shift. Now let's break down the process by which we'll determine all this stuff. So within the graphs of sine and cosine, there are things called periods and amplitudes. The period is going to be when you have the wave it's going up, down, up again. When that part where it starts to go up, and then on the second one where it starts to go up, that distance is what's known as a period. So there's a very specific way to determine the period and the amplitude. With periods, they will always be derived from the same equation, which is 2 pi over b is equal to the period. An example of how we would calculate this is the sine wave has a period of 8 pi. What is b? Well, all you have to do is plug in 8 pi to the equation for the period portion. So you have 2 pi over b as your base equation is equal to 8 pi over 1. All you have to do is cross multiply the two numbers and get 8 pi times b is equal to 2 pi. And you'll divide by 8 pi to get b alone, because b is the variable that you're solving for, as seen in the equation right there. So you'll get 2 pi over 8 pi. You'll cancel out the pi's, so they're no longer there. And then it's 2 over 8, which you can divide 8 by 2, and it'll be 4, so it's 1/4. Now, how do we apply this into the equation? So the 1/4 that we got right here, as it states up here, you'll plug in for the b variable, because as we determined, b is equal to 1/4. Now, how do we determine the amplitude? That's very simple. The amplitude is equivalent to the variable a. So when you see amplitude, you just plug it right on in. But when you see period, you have to do 2 pi over b is equal to the period number that it says. Let's give an example of this. Our example is write the equation of a sine wave that has a period of 6 pi, an amplitude of 2, and a vertical shift down 1. First, we want to determine the period because that's going to require the most math. As we see right here, the period is 6 pi. So we're going to use our base equation, 2 pi over b is equal to 6 pi over 1, because you just want to throw in a 1 to make it something over something is equal to something over something. You're going to cross multiply to get 6 pi b is equal to 2 pi, and then divide by 6 pi, yielding b is equal to 1/3. And then, how do we determine our amplitude? Well, because amplitude is a, and it just very clearly states the amplitude of 2, we know that a is equal to 2. So as of right now, the equation is going to go, or the base equation, y is equal to a sine of b times x minus h plus k, is going to change into y equals 2 sine of 1/3 x minus h plus k. Finally, we want to determine what's going to happen to that h and what's going to happen to that k. Well, that h is a phase shift, right? So nothing is going to happen because there was no mention of a phase shift occurring. However, there was a vertical shift saying that it was going 1 unit down. And a vertical shift, if we remember, is going to be k. So we're going to plug in for k, -1, and we're going to get rid of h because there's no reason to have it in the equation. So the final equation that we're going to have is y is equal to 2 sine of 1/3 x minus 1.